Hello, so today we're going to learn about momentum and impulse, trying to understand how to solve the problems regarding these two topics and making sure we understand the concept around it. Okay, so here we have a bullet of mass 5 grams is fired into a block of wood of mass 1 kilogram that is suspended by two light strings. So the bullet is struck in the block. So it is struck in the block, and the block bullet system swings up to a height of h, right? So which h is given by 50 centimeters. So to write the information given, we know that we're having a bullet that has a mass which is equal to 5 grams, which you can convert. We know very well that 1 kilogram is equals to 1,000 gram. So this 5 gram divided by 1,000 gram multiplied by 1 kilogram is just going to give us 0.005 kilogram, right? So must make sure that all units are in order. So this will be 0.005 kilogram, and we are told that the block is going to rise up to a height of, so we have the block that has a mass of 1 kg, and it's going to rise to a height of 50 centimeters. So the height, we know very well that 1 meter is equals to 100 centimeters. So 50 centimeters divided by 100 centimeters, so this will cancel that. We have 5 over 10, right, which will give us 0.5 meters. So this is just going to be 0.5 meters. So if I'm going to write the illustration of this thing here, so let me remove the information this side so that I can show what's happening regarding the statement that's given. So before collision, we're having this bullet here, and then we have this fixed block with two strings just here, and we are told that this block has a mass of 1 kg, right? So after collision, what happens is this block here is going to rise. So this is what's going to happen. So this string here, so it's something, let me write it properly. So what's going to happen is this. So this block will now rise up. So this is 1 kg. So the bullet will be inside now, just after collision. It will be inside. So it will rise to a height of 0.5 meters, right? So that's what we need to know right now before we answer the questions that follow. Okay, so now the question says that calculate the velocity of the block bullet system. So the velocity of this system here, both the block bullet system, immediately after the bullet enters. So in this problem, we're going to use the mechanical energy equation, whereby we know very well that we have the kinetic energy plus the potential energy initial being equal to the kinetic energy plus the potential energy final, right? So if you remember clearly, we had the block here, which is this one here. So let me write the something that will represent KE plus PE all initial. So we have the block of 1 kg, which is fixed, and we have the bullet. So what we know is that, okay, if we consider this as the ground, or the reference point, so meaning that the height is just 0 here, right? So it means that the kinetic energy of the system, so you're going to just include, so we know very well that kinetic energy is equals to 1 over 2 mv squared. So the m will be the mass of both the bullet and the block, right? And remember, we asked to calculate the velocity of the system, so meaning that this will be the velocity of the system. So if you go back here, we're just going to say 1 over 2, so let me write proper, 1 over 2 mv squared, so the v is for the system, plus potential energy. So as I'm saying, this is just the before collision. So at this point it's just on the ground, right? If you consider this lowest point of the block before collision, that would be the ground, right? So there's no height of the system, so meaning that the potential energy, which is mgh, the height is equals to 0, right? So meaning that PE is equals to 0. So you're just going to say 0 here is equals to, so the kinetic energy of the system after collision. So what you're going to do is, we're just going to say 1 over 2 mv squared plus mgh. So this will be the height, which in this case the height was 0.5. So this is the after collision, so that's what happened. And what we need to note also here is that this block, as we're having a fixed block here of 1 kg, as it rises up to a maximum height, we should note that as something goes up like this, the V final up there is just going to be 0, right? Because the only thing that will act on this block is gravity. So as it goes up, it will reduce in motion because of the effects of gravity and all of that. So meaning that the kinetic energy is just going to be 0. So you have your 1 over 2 mv squared of the system is equal to, so the kinetic energy after collision will just be 0 plus mgh, right? So now let's just cross multiply by 2, multiplied by 2, we have mv squared of the system is equal to 2 mgh. Because we want the velocity, we just divide by m. So v squared is equals to 2 mgh over m, right? So as you can see, this cancels that. Then we have v squared is equals to 2gh, and then when you square both sides, v is equals to the root of 2gh, which in this case, let me rub this, which in this case v is equals to the root of 2gh, the root of, so what is, so it's 2 multiplied by 9.8 multiplied by the height, which is 0.5. remember this height here, and then if you punch this in your calculator, you're going to get an answer of 3.13 meters per second. Let me write the meters correctly. So this will be your velocity of the system after collision. We're done for now. So this second question says that calculate the speed of the bullet before it struck the block. So the bullet, as you remember, it was moving like this. So this is the before collision, considering this block and this bullet here, and then this is just after collision, right? So before collision, we want to find the velocity of the bullet. So we're going to use the initial momentum being equals to the final momentum. So this is the conservation of momentum, right? Whereby this is mv of the bullet plus mv of the block. So this is just bullet being equals to mv. So this is just going to be the initial mv of the bullet final plus mv of the block final, right? So what you need to note is that after collision they combined, right? So we need to combine the masses of the system after collision. So we're just gonna say mv bullet initial plus mv block initial is equals to m of the bullet plus m of the block, all multiplied by the v final, right? So now what you need to note is that the mass of the bullet is equals to let me see, the mass of the bullet is equals to 0.005 grams, right? And then the mass of the block is equals to 1 kg. And we need to note that the velocity initial of the bullet is what's required, and the v final of both the bullet, which is the v final of the system, we calculated above, which was 3.13 meters per second. So this comes from the previous question that we just answered. So now I'm gonna say, okay, fine, mvbi plus mv block is equals to m bull plus m block, all multiplied by v final, right? So we have this, we have this, we have this, we have that and that, and we need that, and we have that. So what is the mass? The mass, we said, is going to be 0.005, and the velocity of the bullet initial plus, so the block initially it was just stationary, so it's just going to be 0 here, and then 0.005 plus the block mass is 1 kg, and then the velocity combined is 3.13, velocity of the system after collision. So we have 0.005 vbi is equals to 1.005 multiplied by 3.13, and then so 0.005 vbi is equals to 1.005 3.13, then divide by 0.005, and the v of the bullet initial is just going to be 1 point, so let me write proper, 1.005 multiplied by 3.13 all over 0.005, and then if you punch your calculator you're gonna get 629.13 meters per second. So this is the velocity of the block initially. Thank you for watching the video. Don't forget to subscribe and write your comments down below.